Example 3. In example 3, we're going to use a calculator to determine the area of the region between 2 cosine of x and y equals x squared minus 1. If we graph both these functions on a calculator, we'll get something that looks approximately like this. You might have to change your window in order to see exactly what I'm seeing. So just looking at this graph, we can see the intersection point is about over here and over here. So that gives us these two values. And again, the idea is that if we zoom out far enough, we're integrating over the x-axis from this point to this point. And so our goal then is to integrate this top function, which is 2 cosine of x, minus this bottom function, x squared minus 1, to get this integral in between. And so now what I'm going to do is show you on a calculator how to do that. And so what we want to do is find the area between the curves. So the first thing we need to do is write down an integral that we're going to put into our calculator. So we want to find the integral from a to b of f of x minus g of x dx. So this is going to be the interval from a to b, and I don't know those values yet because I haven't calculated them on the calculator yet. I know my top function right here is 2 cosine of x minus g of x, which is right here. This is our g of x function, which is x squared minus 1 dx. And make sure you don't forget the parentheses, otherwise it will come out wrong. So this is a, this is b, 2 cosine of x minus x squared plus 1 dx. Alright, now let's talk about how to get this on your calculator. So the first thing we need to do is type both of our functions into our calculator. So you're going to bring up the y equals and go ahead and type both functions in. Alright, now that I have both functions typed in, I'm going to hit graph. And again, this is how you're going to get your graphs in your window. The window on mine might be a little bit different. And so if you look here, you can see the window that I have turned on right now. You don't have to use that window. It's completely up to you. And so now we're going to talk about how to find the actual intersection points. And so to do that, you go hit second, calculate, and you scroll down to intersect, so 5. And then you're going to pick the first curve and the second curve, and then you have to make a guess. So I'm going to guess it's somewhere over here. Hit enter, and it's going to calculate that for me. And what you're going to have to do is write that number down somewhere, because we're going to have to type that in. Then the next thing we do is we're going to do that again. So second, calculate, intersect, and I'm going to pick my first curve is this one, the second's that one, and I'm going to make my guess somewhere over here. And now I have the second intersection point. And again, write that down somewhere. Then what we're going to do is we're going to save those intersection points as an a and b value for our integral. So we go ahead and type in negative 1.265424. And we want to use as many decimal values as we can to be more accurate. And then we store that as a for our lower limit. And then we're going to do the same thing with the upper limit, which was 1.2654. And we're going to store that as the letter B. And now we're ready to integrate. So we hit Math 9. And then we're going to integrate from A to B. And then if you want, you can type in your functions. You can actually type in what we got, which was 2 cosine x minus x squared plus 1. Or you can just hit alpha trace to get y1 minus y2. And we're integrating over x. And you hit enter. And your calculator will do a little calculation and work it out for 4.994907788. And so what we do from here is we just write our answer. So this integral is about 4.994 units squared when you truncate to the third value. Alright, now on your own, I want you to use a calculator to determine the area of the region between y is equal to sine of x and y is equal to 1 minus x squared. Alright, let's see what we get. So when we graph it, it'll look something like this on our calculator. And what we're trying to get is these intersection points. Again, it's important to note which one is our top function and which one is our bottom function. So the top function is right here, 1 minus x squared, and the bottom function is sine of x. And we're trying to find the integral in between, which is going to be about 1.67 when we're done. So then what we need to do is bring up our calculator. So I like to type them in the order that I'm given. So I type y1 as sine of x, and I'm going to type y2 as 1 minus x squared. And then I go ahead and hit graph, and it'll graph those for me. And now what we need to do is find the intersection points. So you hit second, calculate, intersect, select the two curves, and make a guess. So for the first one, I get negative 1.409624. And I do that again. Doesn't really matter what order you pick the curves in. And then the second one's 0.6367365. And so what we need to do now is save those as A and B. So negative 1.4. And we're going to save that as A. And then 0.63673265. And we're going to store that as B. And now all we have to do is do the integral. So you get math 9 A to B. But now remember what we saved them under. We saved sine of x as y1 and 1 minus x squared as sine 2. But by looking at the graph, our top function is our y2. So we need to do y2 minus y1 dx and hit enter. And we get 1.67, which is the correct answer. So if I wanted to write my workout, I would write the integral from a to b of 1 minus x squared minus sine of x dx is equal to the integral from a to b, which is 1 minus x squared minus sine of x dx, which is approximately 1.67 units squared.